why use log scales? Why take a normal linear scale and apply a logarithm to all of those values to make a completely different scale? Typically, the reason is that you're dealing with a massive range of values, and that makes understanding and communicating to one another difficult and really annoying. There are other situations where you're trying to visualize a data set, and you've got some extreme outliers that are wrecking your graphs. And so by applying a logarithm to one or both axes, you get a much better graph and you make better insights. Before getting to the kinds of log scales that apply to your lab, I want to talk about the Richter scale. It's a very commonly taught kind of log scale. So, as you know, earthquakes release energy. That's what causes the shaking and the damage. The energy measured in joules. The Richter scale was invented. It doesn't have any units. You just say magnitude. Magnitude 6.0, 7.0, whatever. This is the formula that's used to convert the energy into the magnitude. We use a log base 10 for that. Now, this is just a ballpark figure, but once you get up to earthquakes of magnitude about 6.0, you're talking about earthquakes that cause damage or tsunamis. For comparison, the very destructive Japan 2011 earthquake, that was a 9.0. The biggest, nastiest earthquake on record, measured with modern instruments, was Chile, 1960. Off the coast of Chile, it was a 9.5. So, I give you those numbers because I want to show you this table. I just said we care about earthquakes of about magnitude 6.0 to 9.5, but look at these measurements in joules. They're brutal. And there are issues of number sense, convenience, and communication where you don't want to say Japan suffered a 794, I believe, quadrillion joule earthquake today. So that number is very hard to read. I had to think before I even knew what word to use for it. The metric system has something that helps us with that. I mean, there are the prefixes, right? There's a terajoule, petajoule, exajoule, but just the same, there are these same issues with number sense. It still doesn't mean a whole lot to me that Japan suffered a 794 petajoule earthquake today. It's very hard to communicate, and so we convert to magnitude. I want to talk about another example of a log scale, which is our regular old number system. Right? Every digit longer, when we write a number, every digit means the number is 10 times as big. 10 is 10 times as big as 1. 100 is 10 times as big as 10. And when you write a number that has multiple digits, each place corresponds to 10 to the 0, 10 to the 1, 10 to the 2, right? And that just keeps going. If anyone's ever made you learn how to write binary numbers, you know this, that each place that you go up corresponds to a new power of your base. This makes communicating much easier. Just imagine if our number system meant that we had to make little tick marks every time we wanted to write a number. You know, a little bit like Roman numerals, only worse. And writing out 100 really does mean writing out all of these tick marks. The pro for this, the silver lining, is that you have an immediate visual sense of just how much bigger 100 is than 10. The cons are obvious. What if I asked you to write the number 1000? You'd be like, nah, I don't think so. So, like I said, log scales help us communicate.